Day 436 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2410, maximum matching of players with trainers. The difficulty level is medium, but don't even worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given the zero-index integer array players where players of I represents the ability of the ith player. You are also given a zero-index integer array trainers where trainers of J represents the training capacity of the jth trainer. The ith player can match with the jth trainer if the player's ability is less than or equal to the trainer's training capacity. Additionally, the ith player can be matched with at most one trainer and the jth trainer can be matched with at most one player. Return the maximum number of matching between players and trainings that satisfy these conditions. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we're doing this problem correctly. So in example 1, we have our input players equals an array of integers 4, 7, and 9. Trainers equals an array of integers 8, 2, 5, and 8. The output is 2. Let's take a look at the explanation so we can see how they got this output from this input. So the explanation says one of the following ways we can form two matchings is as follows. Player 0 can be matched with trainer 0 since 4 is less than or equal to 8, and players 1 can be matched with trainers 3 since 7 is less than or equal to 8. It can be proven that 2 is the maximum number of matchings that can be formed. Okay, so let's break this down one step further, y'all. So we have our players right here. Each integer or each element, each value in this player's array represents the ability of a player, and then we have our trainers array, and each element or integer in this trainers array represents their capacity to handle the trainer, right? So the trainer's ability has to be less than or equal to the trainer's capacity. So in this case, we can match, and we can only match at most, the ith player can only be matched with at most one trainer, and the jth trainer can be matched with at most one player. So we can only match one of these elements with one of these elements. We can't just match two of the players with one trainer. It has to be one player for one trainer. So in this case, we can match this player with this trainer because the trainer's capacity, or the player's ability is less than the trainer's capacity, so they can match and they can work together. Similarly, with this player right here, which has a ability level of 7, it can match with this trainer because it has a capacity of 8. He has a capacity of 8 so he can handle a player with a 7 ability. However, so that's 2 right there. That's 2 matches right there. However, this player right here, there's no trainer whose capacity level can handle this player's ability. Since this player's ability is 9, none of these trainers' capacities are greater than or equal to 9, so he cannot work with any of these trainers. Thus, we can only match these 2 players with this trainer and this trainer. We also would have been able to match this player with this trainer because 4 is also less than or equal to 5, but that's not the match that the explanation used, but that's a valid match though if you chose to make that a match. So let's look at example 2 where they might try to throw a little trick question our way, right? So in example 2, we have our input players equals an array of integers 1, 1, and 1. Trainers equals an array of integers, and it's just 10. This time the output is 1. Explanation says the trainer can be matched with any of the 3 players. Each player can only be matched with one trainer, so the maximum is 1. So since the trainer right here, it says, once again, it says the jth trainer can be matched with at most one player. So since it's only one trainer and he can only match with one player, then the output is 1 because there are no trainers that are able to um, to work with these two players over here. There's just no trainers. There's only one trainer, so there's only going to be able to have one match. So I hope that made sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. Now, the first thing we're going to do is we're going to sort the players and the trainers, which will help us with enabling greedy matching. So we'll say let players equal players dot sorted. Then we're going to do the same thing for trainers. We're going to say let trainers equal trainers dot sorted and put the parentheses. Boom. Then we're going to get the count of each players and trainers. So we're going to say let n equal players dot count. Then we'll say let m equal trainers dot count. Boom. Now we need the count of successful we need to keep count of successful matches, so we can say declare a variable called matches. We're going to set that equal to start just for a default value. And now we need a pointer for our players and we need a pointer for our trainers. So we're going to declare a variable called I, set that equal to 0, and declare a variable called j and set that equal to 0. I for the players and j for the trainers. Now we're going to use the 2 pointers to iterate through the players and trainers. So we're going to say while I is less than or equal to n, because we're using I for the players and n is players.count. And then we're going to say and when j is less than m, or sorry, this shouldn't be less than or equal to, it should be just less than. And j is less than m, that's going to handle our pointer for the trainers. Then we're going to say, we're going to open up the brackets and we are going to say if players square bracket I is less than or equal to trainers square bracket j, then we're going to open up the brackets, and if the current trainer can train the player, then it's a match. So we're going to say matches. We're going to increment our matches count by saying matches plus equals 1. Then we're going to move to the next player by saying I plus equals 1, and we're going to move to the next trainer by saying j plus equals 1. Else, if a trainer can't train a player, we need to try the next trainer, right? So to do that, we could just come right here and say else and say j plus equals 1. Then all we have to do is return the total number of matches that we have found by coming right here and saying return matches. Y'all, that's all she wrote. Let's give it a run before we submit it, though. Make sure it runs properly. And it's accepted, y'all. Let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, 24 milliseconds beats 33.33% of users. We can definitely get those numbers up, but we'll focus on that as we continue down our LeetCode journey. Right now, we just want a solution that is simple and easy to understand so that we can learn from it and we can apply what we learned on future solutions. So with that being said, y'all, make sure you get one more look at the code. This is the top part. And this is the bottom part. And yeah, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.